This equation is much weirder than you think. See, imagine a laser light going through a slit that can be narrowed down, and the laser spot is projected onto a screen behind it. So what do you think is going to happen to that laser spot as we narrow the slit? You see exactly what you would expect. The spot gets narrower and narrower, the sides are getting cut off by the slit. And this makes complete sense. But if you keep going, something strange happens. As you make the slit even narrower, the spot on the screen gets wider. You are making the slit narrower, yet the spot is getting wider. And that's Heisenberg's uncertainty principle. Heisenberg's uncertainty principle says that the more we know the position of a particle, the less we know its momentum, and vice versa. It's written as delta x, delta p is greater than or equal to h by 4 pi. X is the position of the particle and p is the momentum. So delta x is the uncertainty in position and delta p is the uncertainty in momentum. And when you multiply these two quantities, it must always be greater or equal to h by 4 pi. H is the Planck's constant, and don't ask me what is that. It deserves a video all to itself. But for our purpose, it's just a small number. So as we narrow the slit, we were decreasing delta x for the photons. So we were getting more and more precise about where the photons were passing through the slit. And in a certain point, you come to this limit so that if we narrow this any further, you are going to break this uncertainty relation. So what needs to happen is that uncertainty of momentum needs to go up. So if photons were going perfectly straight, now they must veer off to the left or to the right to ensure we don't break the Heisenberg's uncertainty relation. Now this sounds simple until you realize that this equation is telling you that it's universe itself that does not allow certain facts to exist at the same time. Take momentum and position. If a particle has definite momentum, it literally has no position. Not unknown position, no position at all. Mathematically, it's spread across the whole universe, everywhere and nowhere simultaneously. Before you measure it, the particle is not hiding the information. The information does not exist. Measurement does not reveal reality, it creates it. So if the most basic building blocks of the universe do not have definite properties, what does that even mean to say that the universe exists independently of observation?